Hi, my name is Dmitry and I'm thrilled to announce my new video course that will be released next Monday during the Decoded live stream. The course is titled Conscious Angular Testing and it is designed for developers who from one side already have experience in Angular, but they have minimal or no experience in writing tests. This course focuses on bringing that gap, providing comprehensive insights and practical skills for effective and conscious test writing in Angular. In the next 30 minutes, you will see randomly picked lessons from each course section that are still informative and can give you some perception of what to wait for from the full course version. Before you start watching these lessons, I wanted to mention another really cool thing. You have a chance to get the course for free during the giveaway which will take place during the live stream. To take part in it, you have to perform a very few simple steps. Step 1. Share any of my video, just go to the channel and pick your favorite one and share it in your preferred social media like LinkedIn, Twitter, Facebook, etc. Step 2. Leave the comment below this video. This is crucial as winners will be chosen randomly from the comments under exactly this video. And eventually you have to be subscribed to my channel. And this is it. Now let's dive into some demo lessons from the course. Enjoy and hopefully see you soon at the official course launch event. Let's do the very first baby step and try to understand the mental model of the software testing process. It is a very simple concept, but it is very important to understand to not treat testing as something mysterious as many beginners do. In fact, you do testing every single day when you develop some new feature or when you fix bugs. For example, you just created a function that generates an URL. How can you make sure that it works properly? Well, you can simply console log the result of this function, right? And then, depending on the message in the console, you can verify if the function returned the result you expected or not. If yes, then the feature is done. If not, then you have to fix the function logic until it behaves as you expect. And obviously, you have to cover all the if-else branches to make sure that the function is working properly if you provide an array as an argument or if it's just a simple string is provided. The similar happens when you develop something a little bit more complex, like component. For example, to verify that the component properly behaves in the disabled state, you provide a disabled property and set it to true, and then you check the expectation. For example, in my case, I expect that the button in the disabled state should have a disabled CSS class attached, so it will apply appropriate styles like opacity and so on. Also, if I click this button, then any native behavior should be prevented, like form submission or anything else. And once I verify that all conditions met my expectations, then I can conclude that my component works properly. No magic so far, right? This is something we do always to make sure that our code does exactly what we expect. So the main goal of software testing is the automation of this manual process I currently did. So we write another piece of code that instead of us creates the component, sets the property disabled to true, simulates the user click on this button and eventually verifies if the disabled CSS class has been applied and if the default behavior is prevented. We want to automate it to save time because when you have hundreds or thousands of components and functions which might have much more complex behavior and states, then the manual checking can take a lot of time and it is just error prone because you can simply forget to test a certain component behavior and miss the bug. So as you can see, there is no mystery or magic behind the software testing concept. It is just an automation of the manual testing process. That's it. And this is what you have to keep in mind when you will write your own tests later in this course. But now let's move forward and learn what types of tests exist. So see you in the next video. This lesson, I would like to start with a question: what can be tested in our applications? Well, the answer is basically anything. We can test a simple function, we can test a certain component, we can test a feature or the whole application. However, depending on how many building blocks are involved in a specific test case, we should apply different strategies and approaches. So that's why in the testing industry exists three of the most common types of tests. Those are unit tests, integration tests, and end-to-end tests. Now let's quickly go through all of them. Well, unit tests, this type of tests which focuses on testing the behavior of the single unit. For example, a single class, single function, single Angular component, service, and so on. If this unit test has some dependency, for example, the component depends on some certain service, the service should be substituted with a faked variant of this service. It is also known as mocking, and later we will talk about it in detail in this course. But it makes unit tests very fast, which is the main benefit of this type of test, and that's why they take a major part of the coding base. However, since we are faking dependencies in unit tests, we have very little confidence in how our building blocks work together. And this problem solves another type of tests, which is called integration tests. This type of tests are not faking the unit dependencies, but they fake calls to backend. And these tests are very useful when you want to test a feature at all, with all involved components, services, directives, and so on. Integration tests are a little bit slower and harder to write, so that's why we usually write fewer integration tests, but they are very important because they cover parts that unit tests are missing, and namely it is how multiple units work together. And using of these two types of tests might give you a relatively high level of confidence, but they do not verify how the system works in general with the backend and other required infrastructure. And about this part cares end-to-end tests, which are testing the whole application. There, nothing is faked in these tests. There we do real requests to the real backend in the real browser. We render the whole application and so on. This type of test is the most complex because it requires a special infrastructure for it. These tests are very fragile and they are very expensive in terms of execution and resources. That's why the amount of end-to-end tests is usually only about 10%, can be a little bit more, can be a little bit less, but in average it is about 10% of the whole testing code base. And these tests, they cover only the most critical application features and also so-called user happy path. And having these three types of tests can give you quite high level of confidence in your code base, but in this course, we will focus mostly on unit tests and a little bit on the integration ones, because those ones we write in most cases, and those are the kind of tests that we as developers are mostly responsible for. End-to-end tests quite often are the responsibility of QA teams, but it might of course vary from company to company, and Overall, it is a big topic. I mean, end-to-end tests. It is a big topic that deserves a separate course. So that's why we will continue only with those two types of tests in this course. But we are done for this lesson, so let's move forward and see you in the next lesson. In the full version of this course, we will continue to learn basic information about testing. We will even build our own super tiny testing framework to understand the core concepts behind any testing framework like Jasmine or Jest. And besides that, we will start learning the syntax of real testing frameworks without the Angular context so far. The next section of the course is dedicated to some Angular concepts that are crucial for moving forward. So before we write the very first unit test with Angular, we have to recap what is dependency injection, how it works in Angular, how works change detection, and other topics. So now let's have a look at one such lesson. To be successful with unit testing in Angular, it is very important to understand how the change detection mechanism works in Angular. In this video, I will show you just a high-level overview over this process to give you the basic understanding, and I will focus only on the parts that are really useful and important for unit testing. But I highly encourage you to watch my video series about change detection in Angular on YouTube. It is for free, and there you can find 3 videos about that topic where I cover everything really in depth. Links will be in the video description to this lesson, so please find some time to watch that videos. It will be very useful for you, not only to proceed with this course, but also for your daily work with Angular framework. Alright, so what is change detection? Change detection, this is the process of synchronization, the component model with the corresponding component view. We need it because we use some properties of our component model. In my case, it is a class app component, and we use those properties in the view right here, right? And if the value of any of this property changes, we have to re-render the corresponding view accordingly. All right, now let's very quickly think in which cases the state of the component model can be changed. Well, it can be changed anytime when some asynchronous operation has been executed. For example, user could click some button, and inside the click handler we could update any of these class properties. Could it be? Yes. We could perform some HTTP call, receive some new data, and assign it to any of these properties. Could it happen? It could happen. Also, the data can be changed when you use some set timeout or set interval functions, right? So let's, for the demo purposes, use the set timeout, and after some period of time I will update the topic name property and assign a new value. Let's say it is going to be Angular unit testing, like that. And now if I save this change, you can see that after 4 seconds the topic name has been changed to the Angular unit testing. So Angular detected that some asynchronous event has been fired. So now it goes through each binding in the template, like this one, like this, or this property binding. So it goes through all these bindings and check if the previous value is the same as the new one. And if it remains the same, then Angular does nothing. If the new value is different from what was before, then the view will be re-rendered. In our case, Angular, after the set timeout was involved, started to check binding. It sees that, okay, the previous value has been change detection in Angular. Now the new value is Angular unit testing. So this binding has to be re-rendered. Then it goes further, it sees this binding is visible was true and it remains true because it didn't change. So this binding remains the same and this div will be visible, and the same with all other bindings. At this point, Angular detects changes automatically, so it can automatically recognize that, okay, some async event has been fired and it has to run the change detection cycle for every component in the component tree. This automatic change detection process is possible because of Zone.js library. Zone.js library, this is the tool that notifies Angular that some async event happened and it is a time to execute change detection. What is interesting though, you can disable ng-zone for your Angular application. You can do that inside a main.ts file when you bootstrap your component or module and provide the special config called ng-zone and say that you want to provide the noob zone. This is kind of faked version of the ng-zone that doesn't trigger the change detection. So basically this is kind of a mock. You can also think about it like that. So once you save this change and then go to the application, you can see that after 4 seconds the title was not changed. So the property was updated to the new string. This is because Zone.js doesn't notify Angular about a synchronous event anymore, and we have to detect changes manually. The way how we can do that is by injecting a special guy called changeDetectorRef, and it has a special method called detectChanges. This is exactly what Angular calls under the hood when the Zone.js notifies Angular about a async event, but since it is disabled, we have to do it manually. And once I save this change, then after 4 seconds, you can see that everything is working again and the topic name was successfully re-rendered. And please remember this guy, detectChanges method, because in unit tests we will be using it quite a lot, because in unit tests you manually control the change detection process. Yes, you can, in latest version of Angular, you can do it automatically as well, but a lot of unit tests already written with this approach where you manually trigger the change detection. The only difference you will see in the unit tests when you call the detectChanges method, that it belongs not to the changeDetectorRef, but a special thing called fixture. But about the fixture we will talk a little bit later, but the idea is pretty much the same. The goal there is to trigger change detection for the concrete component and its children. Alright, and this is everything I wanted to mention about change detection in Angular, and again I highly encourage you to check out my videos on YouTube about this topic if you want to know in depth how this mechanism works in Angular. Once we learn helpful theory and recap the related Angular topics, we can start writing the very first Angular tests. In the next section of the course, we will focus mostly on testing dummy components, directives, services, and pipes. We will learn different strategies on how to test regular and standalone components, how to test components with the on-push change detection strategy, how to stub view dependencies, and many other things. This section doesn't cover the testing of smart components with observables, HTTP calls, and complex dependencies. This will be covered in the separate section. But now let's have a look at the couple of lessons from this section. If you don't know where to start with unit testing in your Angular application, I usually recommend to start with the simplest building blocks. Those are usually Angular services and utility functions. If you have the last ones, it is a great starting point. In my application, or actually library, I have such a group of functions that are located in the folder utils, and those are pure reusable functions that perform some little operations in my Angular application. For example, it might be checking if the provided value is a number or converting provided value from one type to another one. Those functions might be useful if you want to coerce data received from component or directive inputs to some desired data type, because the native JavaScript data coercing might work not as we actually need it. Alright, now let's cover our functions with unit tests to make sure that they are properly working. And I suggest to start with the simplest isNumber function. But before we write our very first unit test, we have to create a dedicated spec file and create a test suite for this function. So let's go and create a spec file next to original one. By convention, the file name should have the same name as the original one and have a suffix spec. So just like that. Okay, now let's open them next to each other, like that. And here let's create the first test suite, calling the describe function. Here we define that this is a test suite for the isNumber function, right? And inside the callback, we have to define the first test case by using the it function. So what this unit test will be testing. For that, let's have a look at the description of this function to figure out how this function is actually working. And here you can see that isNumber function checks if the value is a number or if it can be converted to a number. And here below you can see some expected inputs and outputs from this function. So if the input for isNumber function is integer 100, then I expect that this function will return true. If I provide a string 100, I also expect that the result will be true, because a string 100 can be easily converted to an integer 100, and that's why it is a number. But if as an input I provide an empty string, then I expect that the result will be false, because my implementation supposed that empty string cannot be converted to a number. The same result I expect if I provide some mixed string that contains integers and strings together, then I also expect that the result will be false. If I provide some object as an argument for isNumber function, then I also expect that it is going to be false, and so on. You can continue as much as you need, but let's stop on these 5 conditions that we're going to check. And each of these conditions is actually a separate test for the isNumber function. So let's write a test for the first condition that verifies that isNumber function should treat integer 100 as a number. And inside the callback, we will describe already the logic for this test. So first of all, we have to execute isNumber function with this given input. For that, let's create some constant like result and import isNumber function. Here we go. So here I provide an input, an integer 100, and then I expect that the result will be true. Make sense? So let's save it and try to run our first unit test. And I have to run npm run test, and I run tests for the project UI kit for my library, right? So I hit enter, and you can see that there was executed one test and it was successful. And also Karma opened the browser instance where you can see this report and make sure that this unit test has been successfully passed. But let's get back to our VS Code and write unit tests for remaining conditions. So the next condition we want to verify is that we will get true if we provide a string 100 as an argument for the is number. For that, I'm gonna just duplicate this test and slightly adjust the description because it should treat this time string 100 as a number. And here, instead of integer 100, I provide a string 100. And again, I expect that the result of this function will be again true. So if I go to the karma report, I can see that I have already 2 successfully passed unit tests. And then you can just continue to test the rest ones. So you just duplicate things again, you adjust the test description, like this time it should treat an empty string as not a number, right? So you provide an empty string and you expect the result is going to be false. And if you save it, you can see that third test has been passed as well. And then you just continue. So then I say that, okay, the string 100 ABC should be not a number as well. So here I provide this input and expect that it's going to be false as well. And the same I can do with an object. So I can duplicate it and say that it should treat an object as not a number, which actually makes sense. And here I provide just a simple object. And if I save it right now, you can see that all my tests are successfully working. And we can actually save a little bit space here by refactoring it and calling this function directly inside the expect function. So like that, I just wanted to be more precise and use this intermediate result constant, but actually to make it shorter, you can do it like that. And let me quickly do the same thing for the rest of unit tests. All right, so I'm back and we can proceed and create a new test suite and group of unit tests that will be testing this toBoolean property function. For that, alright, now let's talk about change detection in this testing environment, how it works and which role plays the fixture. And let's get started with the following thing. Let's quickly investigate the component that we have rendered right here. Actually, this button should look differently from what we see it right now. This is because if we have a look at the HTML of this button, we will not find the special CSS class that has to be attached to the host element, which role plays this div element with the ID root 0. Because if you have a look at the implementation of this component, we have this host binding and we bind the class which name should be combination of the appearance string, so in my case should be solid, and the button suffix. But we don't see it right here, and this is because the initial change detection cycle has not been executed. And this is a big difference compared to the regular Angular applications where the initial change detection cycle is scheduled right after the application bootstrapping. But in test environment, when we create a component, the initial change detection cycle is not triggered. And this is something we have to do manually. For example, let's get back to the browser and try to play around with the change detection a little bit. So here in the console, I still have the reference to the fixture, right? So I can use it and I can call the detect changes method and in such a way trigger the change detection cycle for this button component. So I hit enter and you can see that the appearance of my button has changed and now it got the blue background, and this is because if we have a look again at the HTML of this component, now the host has got this solid button CSS class, which actually brings these styles to this element. And here you can continue playing with that. For example, you remember that fixture has a reference to the component instance, right? So this is the instance of the button component that has appearance property that is currently solid, but we can of course override it and say that now I want to have a stroked appearance, right? And override the value for this property. And if I save this change, you can see that nothing has changed right there. And again, this is because we changed only the property value for the component class instance, but we didn't run change detection in order to apply those changes to the DOM. So for that, we again have to trigger detect changes. And if I run it right now, you can see that the appearance has changed. The background disappeared. And this is because now to the host element has been applied stroked button CSS class instead the previous one, which was the solid button. And this is very important to remember and understand, that every time when you change the value of the component class, you have to make sure that you run change detection and those changes has been applied to the component, which is a big difference compared to the regular Angular application where Angular does it automatically for us. But in the testing environment, we are responsible for that. But change detection, it is not only about the property bindings, right? It is also about triggering some certain lifecycle hooks. For example, let's get back to our component and just for testing purposes extend this button component class with lifecycle hooks like the ng on init lifecycle hook, and maybe something like ng after view checked lifecycle hook that will be triggered every time the change detection mechanism checked the component view. And now let's have a look when those will be called when we trigger change detection manually. So I go back to my browser and here let's try to call the initial change detection. So the very first one for our component. So I call detect changes and you can see that they were involved ng on init trigger because this is the first change detection run and it is executed exactly during this phase. And also ng after view checked, that is executed every time when the view of the component has been checked by the change detection. And if you try to run detect changes again, you can see that now only ng after view checked lifecycle hook was involved, but ng on init was not, because this is already the second cycle of the change detection. So that's why you can very often see that inside the before each lifecycle hook, every time when you just created a component, you can see something like fixture detect changes like that. So this is the emulation of the initial change detection that triggers a group of lifecycle hooks that are executed at the very beginning. Those are ng on changes, ng on init, ng after view init, ng after content init, and so on and so forth. Okay, so this is the emulation of this first change detection cycle that does normal Angular application initially after the application is bootstrapped. So now I hope you have better understanding of how the change detection works in the testing environment. Don't forget to remove these things that we don't need anymore. And yeah, let's move forward and explore other features that brings us their fixture. Alright, this was the end of the course demo version. If you like this course preview, you can continue watching it on my platform because there I offer even more lessons for free, or you can enroll in the full course version and continue to level up your Angular skills. If you watch this video until November 20, 2023, don't forget to join the live stream of the official course launch, and remember about the giveaway and the requirements to take part in it. Namely, the first step, you have to share any of my videos on any social media platform. The second step is to leave a comment under exactly this video. And the third step, you have to be subscribed to my channel. And this is all for today. I wish you good luck, guys, and I will be happy to see you in my course and launch stream.